In late June, 70 researchers and farmers took part in a WA Livestock Research Council by invitation study tour to the UWA Research Farm in West Pingelly. On site, they were treated to a broad range of presentations that provided an insight into the extent of projects underway and the degree of collaboration between WA's livestock research community. The WA Livestock Research Council had the event videoed, and these videos are available online on the WALRC YouTube channel. In this edition, we feature WALRC scholarship students Eloise Boland and Georgia Walsh, and their work exploring the consequences of heat stress.
And it gives me the absolute greatest of pleasure. I'm most excited to introduce these two ladies to you, Eloise Boland and Georgia Walsh. These are two of our 3 WALRC scholarship holders. They're doing their masters at UWA in the heat stress area, and you've been using some of this area as part of your project. So this is why we're standing here. This is it's some really important work that's part of their study, and so I'll hand over to them and we can find out a bit more about it.
Hey guys, as Bron said, I'm Eloise, this is Georgia, and we are 2 of the WALRC scholarship recipients this year. Now, earlier on this morning, Shane spoke about a heat stress project, and both Georgia and I's projects actually fit within that much larger one. So my one in particular is about the impact of shade availability during heat stress on merino joining behaviour and success. So essentially, I'm trying to find a link between heat stress, behaviour and reproductive success. We already know that heat stress has a negative impact on reproductive success, be it for your rams and their sperm or the ewes and pretty much the whole reproductive there. We also know that our climate is getting hotter, and especially post-2000 it's getting a lot hotter, a lot faster. So we're getting hotter days, and our sheep essentially still can't handle it. Merinos have heat stress occur at about 30.6, 30.7 degrees. So even though we do a lot of our experiments at 32 degrees, they still are heat stressed before that. So I'm hoping that I'm going to help farmers essentially with these hotter climates still be able to maintain the productivity and profitability of their sheep, even as that temperature gets hotter, if we can just figure out how to potentially mitigate it. And because we're using natural shelter, so the trees, and we're doing it on such a large commercial scale, it should actually be not only applicable to their own farms, but also very easily replicated for them with potentially just small husbandry changes, such as just your paddock selection. I'm also working with 2 different hypotheses for this. So my first one is that shade availability will reduce heat stress and therefore increase reproductive success. And my second one is that shade availability will increase paddock utilisation. So in order to do this and see if I'm actually right here, I have got 750 merino ewes and 18 merino rams that we've split over 3 paddocks. So this paddock here is actually our high shade paddock, and just across the laneway there you've got our medium shade paddock. And a bit further down the farm we have a no shade paddock, so it's not a single tree in that one. In each paddock we also have weather stations so that we can see the microclimates happening in each one. And for the entirety of joining, our sheep bore these colours. But they have your GPS chip and then your proximity and activity loggers. So when we download the data from them, we should be able to see where each sheep was, what they were doing and who they were doing it with. So that should give me all the behavioural data I need. We have also done the preg scanning already. So that shows obviously your conception rates. So it gives you the initial idea of joining success, at least for your short term. And we are actually still trying to figure out the best way to get the actual lambing and marking to figure out more that long-term joining success via the shade impacts. So really I'm just hoping, first of all, actually some results out of this, but more so for farmers to be able to look out at their sheep, judge their behaviour and then act accordingly so they can identify if they are heat stressed, if they need more shade, or as George is about to talk about, if they need more water. So thank you. I'm now going to hand off to her.
Thanks, Eloise. So as Eloise mentioned, my name is Georgia and I am one of the 2nd WALRC Scholarship recipients for this year. My master's dissertation project is titled Water Consumption during joining under heat stress. And similar to Eloise, this project is part of a broader heat stress project. So as we know, drinking behaviour is indicative of the health and well-being of livestock, particularly during hot and dry months. So my work will provide information on the intricate relationship between shade availability, climatic condition and water consumption. So we're hoping that the analysis of the field data will be the foundation for real-time predictive modelling using room and temperature boluses. This can then be applied on-farm to reduce the impacts of diseases, increase health and well-being and better productivity efficiency of individual animals. So when monitored, producers may use elevated water consumption as premature signs of challenged physiological status and then intervene prior to disease progression and reduce mortality rates. It is intended that these results will provide crucial information to assist the livestock industry in reducing the effects of climate change on the production efficiency of the sheep enterprise. So once the data is consolidated, we are hoping that they'll be able to provide producers with practical information to assist with paddock selection during joining and long-term farm planning to maintain sheep health. So I'll be relaying my findings to Lindley Anderson, who's my producer mentor for my scholarship, and work with her to produce concise recommendations for sheep producers using her insight and practical experience. So sheep experiencing heat stress will adapt to their behaviour to maximise heat loss, and as Eloise talked about, merinos, this is 30.6 degrees as the literature suggests. So we often see increases in shade-seeking behaviour, water-seeking behaviour, increased standing, increased dry matter intake and increased water consumption. So to further understand the effects of heat stress on reproductive performance, there is a need for field studies, which climate cannot be controlled, but the complexity of the animal's environment can be measured, and that's where I come in. So as we know, shade provision and access to clean water sources are the most effective way to mitigate the negative effects that prolonged heat stress have on our animals. So there's three aims of my project. The first one is to establish how shade changes water consumption frequency during heat stress. The second one is to examine the intricate relationship between heat stress, water consumption, water quality, and the reproductive capabilities of ewes. And then also to assess how both ambient temperature and water temperature affect volume consumed. So we've got in these paddocks out here, we've got little water temperature loggers in them. We've also got weather stations on each of our paddocks that are looking at both humidity and the temperatures that our sheep are exposed to. And as I mentioned before, we have a room and temperature bolus that we can use to indicate when the sheep drink. So when an animal consumes water, their room and temperature will decrease, and it's quite a significant drop, which we can then use to indicate when the frequency of the drinking bout, and then we're also going to be developing algorithms to try and figure out the volume that the sheep are consuming. So within each of these three paddocks, we've got varying shade availability, and we've also got, so we've got all of these awesome things that we can use to detect lots of data and hopefully make correlations between how much they're drinking, where they are in the paddock using our GPS data, and also how this correlates with heat stress events.
Just wondering, wool, how much wool they have on? Because quite often you go out and you see the sheep, it's hot as hell, and they're out in the banks. Just wondering whether that has any effect.
They're in full well to answer your question there, yeah.
I'm just wondering, you've taken care of the observing their water intake and the shade usage. Is there any area in your research to look at what human intervention or human monitoring takes place? In my experience, sheep hate to be disturbed when lambing, particularly twinning ewes, and you can come across a set of twins quite accidentally, go away, and half an hour later or an hour later you come back and they've moved from there. But if you'd have not disturbed them or they had not seen you, they'll stay there and bond with their lambs better.
Yeah, so that's why we're trying to figure out the lambing process, because we don't want to disturb them at all. So during joining, I did some observations just in case the collars failed, just would have something. And I essentially would always just be as far away as possible with a pair of binoculars. And if that meant I was staring through a tiny gap in trees, I didn't want to go forward and disturb them anymore. The only other thing we did with them was because there is different food in the paddocks, we did supplementary feed them. So I think it might have been every third day it was. Yeah. And so that was the only time we really went in, but that was just to try and keep it as even as possible. And aside from that, we tried not to go in the paddocks at all during joining. And then, so for the actual lambing, we're trying to figure out the best way to figure out which lambs belong to who without actually exactly that, disturbing them at all.
Usually if we do lambing rounds, usually we'll be in the laneways just trying to, mitigate as much, how often we're coming into contact with them. For this particular project, I think we're going to look at wet and dry versus the individual lambing.
Yeah, that's the latest.
Yeah, I think so, just to try and reduce the impact on that. Try not to disturb the girls and let them do their thing.
Yeah, can I just ask, when you're measuring water intake, I presume that works because you've got a difference in temperature between the internal temperature of the sheep and the water. Mm-hmm. But hot weather, really hot water, how does that work? I mean, do you get the water gets to almost the same temperature as the sheep?
Yes, so in every dam we've got a little water temperature monitor, and then we're also going to be doing some control experiments to see, so we've got 10 degrees all the way up to 30 degrees, increasing by 5-degree increments, and trying to see how the varying levels of water temperature will actually affect the rumen temperature, so what sort of drops we're going to be seeing. And then also we're doing another in-lab one to try and get a bit of a control algorithm to see how much we're replicating the dam. So we'll be having kind of simulation, if you wish, with wind, with different temperatures exposed to the water, and seeing how much it actually varies between, the first top 10 centimetres of your dam all the way down to the couple metres. And then we'll apply that to our field data just so we can, get those control groups and control algorithms in place. That answers your question.